CES is the mecca of consumer electronics. It's always a lot of fun to be here. We've got a lot to tell you today, and so let's get started. To say that consumer electronics has been transformed, revolutionized in every possible way over the last 10 years can't possibly be overstated. So much has changed. You could say that it all started with the iPod. With our music on our PC organized by iTunes, iPod made it possible for us to take it everywhere. Their catchphrase, 1,000 songs in your pocket, made it possible for us to enjoy music anywhere we want it to be. Then several years later, Amazon introduced the Kindle and made it possible for you to enjoy books in a really convenient way. Download a book in just 60 seconds without even being connected to the PC. All of it untethered just from the cloud. Several years after that, the cloud became even more powerful and started to stream video to your television. Soon clients cropped up. You could stream video and television and movies all the way to phones, tablets, and anything with a smart application processor inside. And today, your mobile devices can also stream. Phones can stream to wireless jam boxes, and your iPad could stream the movie you just made on a vacation to the AirPlay, over the AirPlay protocol, to the Apple TV connected to your television. So now all of a sudden, within just the course of 10 years, everything has changed. Your digital device could enjoy music, movies, books, connected to PCs, unconnected to anything, enjoyed it right from the cloud, and also to enjoy it on any device, any screen, television, phones, PCs, and otherwise. Everything has changed. Now the ironic part of it is that all of this has changed, and it didn't include the single largest entertainment industry. Whereas music and movies and books are now enjoyed in this wonderful new way, video games, the largest industry of all today, can't benefit from this style of entertainment, untethered. It is impossible for you to enjoy your video game on any device. The same video game on any device. It is impossible for you to be untethered. And so the question is, what is it that we have to do as an industry, and what technologies have to be invented to make that possible? And so today, over the course of the next 90 minutes, we'd like to talk to you about some inventions, some new products, some new ideas we have to make this giant step forward in how we enjoy video games. But let's start with PCs. PC gaming is thriving. PC gaming is thriving. These games are huge blockbusters. When I said earlier that video games is now the largest industry, the blockbusters are also the largest events when they come out. Call of Duty Black Ops 2 was introduced to a blockbuster, 24 hours, $500 million. No movies in history, no entertainment media in history has ever rivaled that introduction. 2 weeks later, Black Ops 2 did $1 billion. One single genre of video games, MMOs, massive multiplayer online games, does $13 billion a year in revenues. To put that in perspective, NFL does $9 billion. That's one single genre. To say that video games is a massive entertainment industry is really an understatement indeed. And yet, on PCs, you see innovation happening faster than just on any other platform, because fundamentally it's open. It's innovating constantly. Anybody can participate in it. Any video game developer could create games for it. And as a result, new ideas are fostered. Free-to-play games now represent the fastest growing sector. League of Legends is a phenomenon like no others. Not only are free-to-play games and game developers innovating, the gamers themselves are innovating. The gamers are publishing themselves. The gamers are creating their own software, creating their own content in these free-to-play environments, and selling the digital goods. You hear stories, somebody in a video game creating a hat or creating hats and selling it over the course of a year, generating $100,000 a year. So all kinds of great innovations from game developers to gamers and the industry itself. As wonderful as the PC industry is, though, it is awfully chaotic as well. It is really one of its beauties. Whereas the game console is always stable, one single configuration, the installed base, all one common configuration. In the case of an Xbox, for example, 3 cores and GPU of about 240 gigaflops. The PC industry has a range of personal computer configurations based on your price, based on when you bought it. Just to give you an example, a high-end PC game today, or high-end PC today, has a Core i7 with 6 cores, and a GTX 680 with 3,250 gigaflops. 15 times more powerful than a game console. And it has to range all the way down to an integrated graphics PC with 2 cores and 125 gigaflops, or about half the performance of a game console. And the installed base has configurations that have shipped over the course of the last several years, and as a result, you have hundreds, thousands of different configurations that have to be accounted for. Well, the game developers came up with a great idea. It's called game settings. Now, these game settings allows you to configure the game so that you can reach the full potential of your PC. With different settings of resolution, texture fidelity, the environment settings, the draw distance, the amount of trees, the amount of particles, even great things like anisotropic filtering, because we know that 3D graphics filters and textures are in 3D space, very different than a video and photograph, which is in 2D space. The filtering technology has to be different. The way that the lighting is done, companies like ourselves create technologies like screen space ambient occlusion, SSAO. All of these technologies are so confusing. How is it possible that a game player could possibly understand these different technologies and how it impacts the game? And how could they possibly, with all these different configurations and all these different PC hardware that they have, how could they possibly find the best settings? Well, it turns out that about 7 years ago, we had just created this new GPU called G80. Does anybody know the G80 code name? Okay, so it's GeForce 8800. The GeForce 8800, I was so proud of it. I took the first one home, I took it home to my son Spencer, and I said, hey, install this new graphics card, you're gonna love it. And so while he was installing it, I went out of the room, I came back a few minutes later and I said, okay, well, how's it look? And he's already playing. I think he was playing Call of Duty, he was already playing. And I said, well, did you change the settings? I mean, I want to see it amped up. And he says, Dad, I just want to play the game. I just want to play the game. And why can't you guys just set it for us? Now, I told him 7 years ago, I said, son, this is technical. That's why they pay us the big bucks. There's a lot of technology in here. How do you just set it automatically? It's not possible to. Well, quietly, I knew that he was right. The fact of the matter is, it's very unlikely for all the game players to figure out all the vast number of configurations. And so we went off and undertook an enormous project. We went off and we tried to characterize every single configuration of PCs out in the world, understood every single setting in every single game, and through heuristics, simulation, and very, very expert, detailed game playing, came up with a technology that makes it possible for you to set the games automatically inside your PC. We had to create the algorithms necessary, the methodology necessary to do this, create a server farm, connected it to a cloud database, to a client that we developed. that you can install on your PC so that this can be done automatically. So 7 years later, ladies and gentlemen, and Spencer, on behalf of all the engineers at NVIDIA, the hundreds of man-years of work that has gone into it, the inventions, the breakthroughs, we'd like to introduce you to GeForce Experience. Now, GeForce Experience, let me tell you about GeForce Experience. Well, the way that it basically works is we start by understanding the profile of every single game. We understand the settings. We know through heuristics, through simulation results, and through benchmarking, the performance characteristics of every CPU, GPU resolution combination of PCs in the world. By studying the install base, we can figure out which one to prioritize for. And then we use our expert gamers to literally play through these games to figure out what the settings are. Update them into a cloud database. And before you need those optimal playable settings, and before you need those optimal drivers, optimized drivers, this client would alert you and let you know to install it. And you can opt in to install all this. When you launch the game, GFE magically inserts the settings into your game so that it comes up in the most beautiful and the most playable settings that your PC allows. And so as a result of that, he who buys, or she who buys the best PC gets to enjoy a game in its most wonderful possible way. Now to show you, why don't we play some of the, we're going to show you now an example of one of the games. This is the latest Call of Duty. And this is a video of before we did the setting change and after we did the setting change. Okay, so first, let's play the video, please. This is a standard out-of-the-box settings. This is standard out-of-the-box settings. Call of Duty, you download Call of Duty from Steam, and you launch this game on a GeForce GTX 680. This is out of the box. This is exactly the way it looks. And it's a wonderful game. Incredibly fun to play. If you're playing the game console, it looks approximately like this. It comes up in resolution of 720p, and it's incredibly playable. Wonderful playable. However, if you had GFE installed, the GFE comes now bundled with our drivers. If you had GFE installed and you simply clicked Optimize, this is what you see. So let's show you one more time before GFE optimization and after GFE optimization. You see the slider bar? Before GFE and after GFE. The textures are much, much higher resolution. The rendering is higher resolution. You can see the watch. It's actually a watch. And if you go all the way to the left, there's two soldiers there. And now you can see them crystal clearly. So that's it, the benefit of GFE. The first thing we would like to do is create this client connected to the cloud that makes it possible for everybody's PC gaming experience to be as optimal as it can possibly be. And therefore, as a result of that, give you the simplicity of a game console, but the performance, scalability, and the performance of a PC. Something that has never been done before. We're incredibly proud of it. Now let's talk about something else. The cloud. Cloud computing has obviously changed everything. Its impact on the computing industry, the disruptions to the industry, the disruptions to the companies, can't possibly be overstated. It's all made possible because somebody figured out that instead of single applications running on each, installed and running on each of every one of our computers, a single installation of software in the cloud over the web, serving every user as a service, would revolutionize computing. That same service is now possible as a result of being located in the cloud to run on phones and tablets and PCs of different operating systems, computing devices of all kinds. I could probably guess that it went back all the way back to Hotmail, was my first exposure to a cloud computing applications. But since then, applications after another have really changed the way we use computers. To make it possible, something critical has to happen. The infrastructure cost of delivering that service has to be incredibly low. And over time, as the infrastructure cost of data centers continue to decline as a result of Moore's Law, result of multi-core CPUs, the result of virtualization technologies, it has made it possible for us to deliver these services much, much more cost effectively. And as bandwidth and broadband continues to pervade the world, and we are now able to access broadband literally in everybody's home, and pretty soon in everybody's mobile device, the accessibility of cloud computing becomes greater than ever. There's no question at this point this is the best way of using computers. Oftentimes you buy a new computer these days and there's just no reason to install any software anymore because all of the software that you use are off in the cloud. Now the question is, why is it that this cloud computing architecture has benefited applications, has benefited maps, has benefited videos and music and books? Why is it that this technology and this incredible revolution in computing has left video games behind? Well, the fundamental reason is because video games is a unique medium of its kind. For those of you who use 3D graphics, play games, you understand this very much. Each and every single frame of a 3D graphics application was computed right then. Unlike a pre-recorded movie, where the movie is stored off on disk, and when somebody wants to play Iron Man 2 on Netflix, that disk file is being accessed and simply passed along in H.264 format to the end user, where it's decoded lightly using a video decoder. 3D graphics, on the other hand, the application, the textures, the objects, the world is being completely synthesized every time you touch that computer. Every single frame is being recomputed. The lighting, the character animation, the physics within it, the gameplay, the AI, how should the fighter respond to your moves, are all being computed in real time for every single frame. And so 3D graphics is in fact a rather unique digital medium, and its benefits are very clear. It allows you to be suspended in disbelief, allows you to enjoy an application in a different way every single time. And so the question is, what problems do we have to solve? There are 4 things we have to solve. We have to figure out how to make it possible for our GPU to render not to a display connected to HDMI or DVI, but to render directly out into the cloud. To render it in a remote way, in a very low latency way. That's the first thing we had to do. The second thing we had to do was to create a server system, because these data centers are racks and racks of servers, and these servers are used for general purpose computing. Lots of CPU cores and no GPU cores at all. We had to create a system that was dedicated and optimized for high density video game streaming. So this one server has to be dedicated really to computer graphics, optimized for computer graphics, to deliver the performance and to deliver it in a very efficient and very high density way. We also had to create a software stack. No software stack exists today that allows a singular computer to support and to connect to hundreds, thousands, millions of users and make it possible for each and every one of them to have a unique experience. And then lastly, we had to create a piece of software that sits in every type of computer as a client, as a receiver, that allows us to receive the streamed data in a very low latency, very high performance way. These 4 pieces of technology literally took us 5 years to create. Took us 5 years to create. And I'm incredibly delighted today to introduce you to NVIDIA's first fully integrated product. A fully integrated system product. NVIDIA, the NVIDIA Grid. What you're looking at is the NVIDIA Grid. Each one of these servers are designed and optimized for computer graphics. And within each one of these servers are packed full of GPUs. Just packed full of GPUs. And all of these GPUs are able to run concurrently, supporting many concurrent users at one time. Initially, we'll be able to support something along the lines of 24 concurrent users on one computing node. The way to think about that is, today, your PC supports 1. And so we'll be able to support 24 times more concurrent users right off the bat with a computer that occupies about the same amount of space as a desktop computer. So this is the NVIDIA Grid. Well, let's compare it to a few things. So this particular rack has about 20 grid servers in it. It's packed with about 240 NVIDIA GPUs, which gives you an aggregate 200 teraflops of GPU computational performance, which translates to about 720 Xbox 360s. Now, just to put it in perspective, 720 Xbox 360s is 10 racks. It would occupy the volume of about 10 of these racks, basically going all the way down the stage. It would consume about 5 times as much power as this one. Not to mention all the software that makes it possible for us to provide the connection broker with the end user that comes to enjoy the game. All of the load balancing and quality of service provisioning, and promising that that quality of service is now delivered on this particular piece of software. It is a virtualized piece of software, essentially a hypervisor that supports both CPUs and GPUs. Why don't we see what it can do? And so let's introduce Andrew Fear. Come on up here, Andrew. Andrew is going to, is a product manager for NVIDIA Grid. Now what we're looking at here is a smart television. This is a smart television from LG, and the only thing that's connected to it, just so you know, we should take one of those rings. There's nothing connected to this except for Ethernet. Okay, the backside of this is simply Ethernet. Ethernet goes into a router. The router goes into an NVIDIA Grid. That UI that you saw just a second ago, the Grid UI, that entire layer of middleware, that UI was rendered in the cloud. That UI wasn't rendered here. As a result, you could imagine whatever UI, whether TV is this model or that model, so long as it's an Ethernet jack and an application processor, that UI could be exactly consistent. You don't have to port the UI and the client for every single one of the televisions out there. Andrew, what are you playing here?
So I'm playing a game called Trine. It's a pretty fun game. I've been playing it for a while now. I'm a big fan of the series. And what I like about the game is, you know, when you tell people, you know, what do you do in the game? Well, you're a wizard, you're a thief, you're a mage. I like to think of it as, I'm a guy with a sword, I'm a girl with a grappling hook, I'm a guy with a magic wand.
And you're all that at the same time.
You're not all that at the same time. The Trine is this magical object that lets you sort of change characters as you go. So when you're trying to solve puzzles and save the world, You can change a different character, you have different things. You can see here's my girl now running around with her grappling hook. And it's kind of fun. It's a beautiful world. It's completely rendered. The graphics are beautiful and smooth. And again, this is something just amazing for me to see this rendered all locally right here.
That's amazing. And so we're looking at a television that's, this is the latest smart television from LG.
That's great.
And all we've done is we've taken the Grid receiver client and they've ported that Grid receiver client to their television, and as a result, once you plug in Ethernet, you could stream the video game that's processing on one of these GPUs on a Grid server.
No, absolutely. Now, what I love about it is that you get access to all these games instantly on a TV. But I'm sure, like me, you travel a lot, right? You can't take your games with you all the time. You have saved games, like I'm doing now. I'm saving this game. And one of the things that I like to do is, after I'm done playing my game, if I go on the road like CES, I don't have access to these games.
Now this is cloud computing.
Well, it is cloud computing. The thing that I like
cloud computing. So what could you do with cloud computing?
Well, the thing I like about cloud computing is that if I bring a device with me like my ASUS Transformer Prime, I can easily launch the Grid application.
Now go back. I think that they didn't change the view fast enough. Go back to, so this is a transformer. This is now an Android tablet, and there's a little client on there called NVIDIA Grid.
That's correct.
Right? Now this could be the Transformer Prime. This could be the Nexus 7. It could be a Galaxy Tab. It could be right HTC One X. It could be. Frankly, it could be an Xbox. It could be anything. Right? It has anything with enough, and it doesn't have to be very much. I mean.
It's just encoding video at the end of the day, right? So you can do lots of different devices.
So you launch this little client, and magically, amazingly, exact same UI shows up. This is the same UI that we showed.
All the games that I had over there, I have over there. And I think what makes it really amazing, as I said, is if I go on the road and I always try to, I want to do the right thing and I try not to get into trouble on the road. If you play games, it's a great secret. Don't get into trouble, you play games on the road then. And you can see here where I was in the game. I'll just go ahead and I'm going to go to single player and I'm going to load that save game I had just a second ago. And you'll see that I'll pick up playing exactly where I was on the television.
Oh, no way. All right.
There's my guy from the Flaming Sword. I'm a big fan of this guy. I'm a pretty simple guy when it comes to things. And, I like boulders and rocks and flaming swords.
So this is fantastic. So first of all, you're getting a graphics experience. You're getting a 3D gaming experience that isn't possible on even a Transformer Prime today. But the fact that you have the game in the cloud, you can get all the same benefits that you would have had with Kindle books or
absolutely
any of your cloud applications.
Just
wherever you left off, you pick up.
Absolutely. Like you can pick up your videos, watch them anywhere you want, pick up your games, play them whenever you want on any device.
Oh, that's terrific. All right, congratulations. Thank you. And so the NVIDIA Grid is our first fully integrated system product. And we sell it to MSOs and to partners who are serving MSOs and anybody who would like to host and would like to stream cloud games. Today, we would like to announce some of our early partners for NVIDIA Grid. These are really innovative companies, and they're from all over the world. Agawi is here in the United States. They're working with Microsoft, and they've been working on streaming Windows 8. You have G-Cluster, which is based in Japan, and they're working with SFR, and they're working with Orange. You have Playcast based in Israel, Ubitus from Korea, and they're doing trials right now with Docomo and Verizon. And you have CyberCloud and Cloud Union doing trials in China with some of their telcos. As you can see, cloud gaming is an industry that is about to come to fruition. The enabling technology, NVIDIA Grid, has taken us several years to create, and finally has been put together in a way that can allow these companies, our partners, to deploy cloud gaming globally and in a very, very large way. And so I want to thank all of our partners for joining us with NVIDIA Grid, and I look forward to seen the successful trials with these large telcos and the many more that will be coming. I also want to thank all of the engineers that have worked night and day. You know, these projects, this particular project is our first fully integrated system. We had to architect a brand new GPU. We had to architect a brand new system from the ground up dedicated to this application. All of the system software that makes it possible to provision this quality of service and this complexity of service over the cloud, and also all of the client software that's out there. All of these are first of its kind inventions, and it's taken us 5 years to make it possible. I'm incredibly proud of the engineers that have made it possible, and let's give those guys a round of applause.